Today, we are cracking a code that, believe it or not, shapes all of our lives, the climate code. We're going to dive into how scientists actually make sense of the totally wild and wonderful weather patterns all across our planet. And we'll start with a puzzle that seems to defy all logic. I mean, seriously, how does this happen? It's a real head-scratcher. You can have a place like India's Thar Desert, which is just relentlessly hot and dry, and it's right next to areas that get absolutely drenched by monsoons every single year. How does our planet create such dramatic, whiplash-inducing contrasts side by side? Well, that's the mystery we're going to unravel. You know, when you first look at a world climate map, it just seems like a chaotic splash of color, right? But what if I told you there's a hidden logic to it all? For over a century, climatologists have been building systems to organize this complexity, to turn that seeming chaos into a clear, understandable map. To make sense of that map, we first need a common language. And the most famous system out there, our first stop on this journey, is the Koppen climate classification. Think of it as the Rosetta Stone for understanding global weather. So, this system was developed by a German climatologist, Vladimir Koppen, way back in the early 20th century, and it is just beautifully logical. It looks at a few really key things: how hot or cold is a place, how much rain or snow does it get, and crucially, when does it fall? See, Koppen's genius was realizing that these simple numbers directly lined up with the kind of plants that could grow there, making it the first system to really connect climate to the living world. Let me put it this way. Trying to study climate without a system is like walking into a massive library with no catalog. It's just impossible. The Koppen system is that catalog. It gives every single climate a specific code, like a call number for a book, so we know exactly where it fits and what it's like. Okay, so at its core, the system starts with 5 main groups, just labeled A through E. A is for tropical climates. We're talking consistently hot, like the Amazon. B is for dry climates. Think the Sahara. C is temperate. That's where you get 4 distinct seasons, like in a lot of Europe or North America. D is continental, famous for its huge temperature swings between summer and winter, like the American Midwest. And finally, E is for the bitterly cold polar regions. Each letter is our first big clue. And boom! When you apply just those 5 basic letters to a world map, the planet's hidden logic really starts to pop. You can clearly see that tropical belt in red hugging the equator, the massive dry regions in yellow, those green temperate zones where so many of us live, and then the continental and polar areas pushing up and down towards the poles. This is our first layer of organization. All right, now to really see how powerful this system is, let's zoom way in on one country that has a little bit of everything: India. It's a true climate microcosm. And this is where the system's real power shines. You see, this map isn't one solid color. It's a beautiful, complicated patchwork. The Koppen system uses extra letters, these detailed subcategories, to map out this incredible diversity. So let's take a quick tour and see what these codes actually mean on the ground. Okay, first stop, the western coast. Here we find the code AMW. So what does that mean? The A tells us it's tropical. The M stands for a monsoon-style rainfall pattern, and that little W tells us it has a dry winter. Put it all together, and that code perfectly describes the rhythm of the region: a long dry season followed by months and months of heavy summer monsoon rain. Now, let's just hop a few hundred miles over to the northwest into the Thar Desert. The code here is BWHW. Okay, let's decode it. The B means it's a dry climate. The capital W means it's a true desert, not just semi-arid. And the H means it's hot all year round. It's a totally different world, defined by extreme heat and almost no rain. Now check out that huge swath of land in the north, labeled CW. This is the Great Indo-Gangetic Plain. The C tells us it's temperate, so hot summers, mild winters. And that W again? It tells us the winters are dry, with all the rain coming from those summer monsoons. And now for the biggest surprise of all, let's go all the way north into the Himalayas. Here we find the code ET. That E, that stands for a polar-type climate. Yep, at these extreme altitudes, even in a subtropical country, you get an alpine tundra, bitterly cold with pretty much no growing season. Isn't that incredible? A polar climate just a country's breadth away from the tropics? So, the Koppen system is amazing, but it's not the only game in town. It's not the only way to read the climate story. So let's switch our lens and see how a different system builds a totally different picture. Let's talk about the Thornthwaite system. Okay, so while Koppen is all about temperature and rain, Thornthwaite asks a different and really crucial question. What's the water balance? It compares the water coming in from rain with the water going out. And that outgoing water is what scientists call evapotranspiration. It's basically a combo of evaporation from the ground and water used by plants. So here's the bottom line. They are two totally different lenses for looking at the same world. Koppen tells you, what does the weather feel like? Thornthwaite tells you, is there enough water here to support life? Is the land in a water surplus or is it in a water deficit? And would you look at that? See what happens when we apply that lens to India? The map completely transforms. It's no longer a story about temperature zones. Now it's a story about moisture. You can see this clear gradient from the deep brown, arid desert in the west, all the way to the deep blue, humid or super wet regions in the northeast and along the coast. Okay, so these codes and colors are fascinating, but you might be thinking, why does this actually matter in the real world? Why do we spend so much time and energy mapping climate? Well, the answer gets right to the heart of how we build our world. These are not just academic exercises. Understanding a region's climate code, especially its water balance, is absolutely essential for our survival and prosperity. It dictates literally everything, from what we can farm to where we can build our city. So, when you boil it all down, these climate codes are intensely practical tools. They help farmers decide which crops to plant and where to plant them. They allow engineers to manage our incredibly precious water supplies, and they give ecologists the vital information they need to protect our planet's diverse and fragile ecosystems. This is how we solve the puzzle of a desert next to a monsoon, by understanding the precise balance of heat and water that defines them both. Which leaves us with one final and pretty urgent question. These maps are a snapshot of our world's climate as it is, or as it has been. But we all know our planet is changing. Deserts are expanding, rainfall patterns are shifting. So the real question for our future is, what will these maps look like in 50 years? And are we prepared for the changes they're going to show?